All right, 3.2, I know it says 3.2 soil up there. This is 7.3 soil. The PowerPoint and a lecture for it, all right? So soil is part of the regolith that supports the growth of plants. Regolith is just that material that's on top of the earth. Sand, dirt, rocks. So regolith is a layer of rock and mineral fragments that covers most of the land's surface. And soil composition. Soil has four major components: mineral matter, broken down rock, humus, which is the decayed remains of organisms, water, and air. Here we are. Here's the the mineral matter. Air is 25%, mineral matter 45%, water is 25%, and organic material, humus, is 5%. Now, it varies on different locations, okay, on the earth. What are the characteristics of soil? Texture refers to the proportions of different particle size. There's sand size, silt size, and clay size. Sand size is the larger pieces and clay is smaller. Loam is a mixture of all three sizes. It's best suited for plant life. So when we have all three of these mixed together, that's what we're looking for. Here's our soil texture guide. Here's mostly clay, some silty clay, silt clay, loam, clay loam, silty loam, silt, and you can see how we work this. If you have a 80% silt, you would go right here, 80, 10, and 10, you're in this area. So if I had 80% silt, 10% sand, and 10% clay, I would be right here in a silt or a silty loam. That's the way you use this. If you have a 40% clay, you're going to come across here, 40%, and here would be 30%, that's 70, so we'd have to go down to 30 over here, boom, right here, boof. And all the lines that connect right here will equal 100%, okay? If you go here, I have 50% clay, 10% clay, 50% sand, and my silt would be 40%, okay? So that's the way this chart works. Characteristics of soil. Soil particles clump together to give a soil its structure. The most important factor in the soil formation, that soil that's in your backyard, the soil that's behind the school, across the street from the school. The most important factors in that soil are the parent material, the time that it's had to form, the climate, what kind of organisms or organic life there is there, and the slope. How steep is the slope? So parent material. Parent material is a residual soil. Parent material is the bedrock. It's the bedrock. It's that bottom area. Transported soil. What was transported here? Parent material has been carried from elsewhere and deposited. So residual soil is what's originally there. Transported soil is parent material that's come from someplace else. Dropped off by glaciers, dropped off by the river, whatever. And here we go, parent material and soils. Here's our bedrock, all right? And here's unconsolidated deposits. This is from the river. These deposits are residual soil right in here. And that's from a deposit. Transported soils are on top here. So the parent material and the soil. Parent material and the soil. Then we have time. Important in all geological processes is in time. The longer a soil has been forming, the thicker it becomes. So the longer it's had to form, the thicker and richer that soil will be. And climate has the greatest effect on soil formation. Organisms. Organisms influence the soil's physical and chemical properties, and it furnishes organic matter to that soil. Dead animals, dead plants, all that gets tossed around in that top layer of soil. When I was a kid, they would just, when you were done with your field, you plow it under. They don't plow as much now as they used to, but they plow the old dead plant material under to help with the soil. And then the slope. Steep slopes often have poorly developed soils because they run off. An optimum slope is a flat to undulating upland surface. So we like to have the flatter an area is, the better the land development. Slope orientation or direction of the slope is facing influences soil formation. When you're on a slope, if the slope side or the face side of the slope, you might not know what the face side is, but that's the slope side. If it faces the sun, it's going to have a different temperature. So it's going to have a different type of soil on the slope or on the face of a slope. And of course, the moisture. How much moisture is that going to get? Is it on the leeward side? Is it on the rain shadow side or the rain side of the slope? It's going to affect moisture. Soil profile. Soil varies in composition, texture, structure, and color at very different depths. Soil horizons are zones or layers of soil. A soil profile is a vertical section through all the soil horizons. And I was going to say, I should have said at the beginning of this, if you've had Mr. Staley for class, you know some of this already because he does these soil profiles. A horizon is commonly known as topsoil. B horizon is subsoil and contains clay particles washed out from the A horizon. The C horizon is between B horizon and unaltered parent material. Here we go. Here's our A horizon. Our B horizon is going to have more clay in that end. The C horizon has a lot of parent material up in there. Okay, it's being weathered. Here you can see it breaking down, and it's in here, and eventually this all gets mixed together. And then, of course, on the bottom, the unweathered parent material. So profiles showing different horizons, and you can see the horizons right here. You have this down here. There's another one down here, but you can see here's A, B, C, and then the parent material D. It's pretty cool. So again, A, B, C, and D. Wow. I said D, but it's the unweathered parent material. You can see that again here. Here's the weathered, that mixed up area. Right here, we have the clay and then the topsoil. Three common types of soil are petal fir, pedicel, and laterite. Petal fir is best developed under forest vegetation and an accumulation of iron oxides and aluminum-rich clay in the B horizon. Pedicel accumulates calcium carbonate associated with drier grasslands, and laterite, which is hot, wet, tropical climates and intense chemical weathering. Usually these soils are acidic. Soil erosion, water erodes the soil, and the rates of erosion, human activities that remove natural vegetation such as farming, logging, and construction have greatly accelerated erosion. Sediment deposition. Reservoirs fill with sediment. Sediments are contaminated by pesticides and fertilizers. So when we use pesticides and fertilizers, we're destroying the sediment, all right? And as we remove vegetation, we are also destroying or causing erosional rate to increase when we get rid of natural vegetation. How can we control erosion? We can plant rows of trees called windbreaks, terracing hillsides, plowing along the contours of a hill, and rotating those crops. That's it. So I hope this helps with your homework. I hope this helps with understanding more about the soil.